Hi, I'm Anshuman, and today we'll be talking about OOPS concepts. OOPS stands for Object Oriented Programming. It's a programming language model that emphasizes more on objects and its behavior. Previous to object oriented programming, trend was to emphasize more on the procedure. That was fine and acceptable for some manageable size of code. But adding or removing feature was very tedious and took longer than expected. With OOPS introduction, data and logic are now bundled into individual software objects. For example, if I am writing a code to emulate an employee, for my application, I would concentrate more on employee related data and its behavior. I would temporarily forget about rest of the application functionalities. Well, almost. Benefits of OOPS. Let us talk about some of its benefits now. Modularity. You can now independently write and maintain source code for an object. Once object is created, you can pass it around the software that you are creating. For example, if you are creating a software payroll management system, we can now individually write and maintain employee related logics into employee class. A change in payroll policy would have absolutely no or very less changes required in employee class. Code reusability. You can now use the code written by someone else into your application and don't have to go through the pain of writing that code again. Easy pluggability. If one module doesn't work for you, find out a module that works for you and replace the non-working module by modifying absolutely no code or few lines of code. An example could be log writing module, also known as logging module. A module that works for Windows native logging might not work for Linux. So you will have to find out a module that works for Linux and then go ahead and change it. Easy debugging. For debugging, you can concentrate on the code section that could be causing the bug instead of running through the entire source code and finding out where the bug is. This makes you as a developer very happy and makes your life a lot easier. Let's try and understand a little bit more about objects. If you check out the definition of object, it says anything that is visible or tangible and is relatively stable in form is called object. Example could be you, a dog, table, chair, fan, anything that fits into this criteria. If you observe them closely, every object shares two characteristics, state and behavior. Take a person for example. Their state could be name, age, height and weight. And behavior could be the way they talk, walk or eat. Let's take another example, say a dog. Their state could be name, color, breed, or behavior could be the way they bark or wag their tail. Let us see how these real world objects can be represented in software. It's simple. State are stored in fields or variables as data, and behaviors are exposed through methods or functions. These variables and methods can be used in software world to emulate real world object states and behaviors. So the question is, where would you write these variables and functions? And answer to that is class. This is the reason why class is also known as blueprint of the object, because an object created would have same states and behavior that you define in the class. There are non-class based programming languages, also known as prototype based programming languages, but we will not talk about them today. Now we know what objects and classes are. Let us talk about OOPS key features. Inheritance. Inheritance allows child to inherit properties of its parent. This also gives child class the opportunity to override any of the behaviors inherited from its parent. In the example shown here, Rectangle, square and circle are children extending its parent called shape. So by default the behavior draw from parent class shape is available to all child classes. So child class can either continue to work with inherited behavior or would completely rewrite it to suit its requirement. The pic on the right is from the movie The Good Dinosaur. In one of the scenes, that dinosaur says to the kid dinosaur that you are me and more. This can also be rephrased as kid dinosaur already has all the capabilities that dinosaur has. But at the same time, kid dinosaur can be more than what that dinosaur is today. Polymorphism. Polymorphism in Greek means many forms. It also means ability to take multiple forms. So if a variable is created of parent type, it can refer to any of its child object and only runtime associated object behavior would be called whenever program runs. Let's see an example. In the picture on your left, if a variable of type shape is created, it can refer to any of its subclass, that is either rectangle, square or circle. The code representation is also there as an example. So the shape knows that there is a class named rectangle at compile time, but how it would behave when the method draw is called would be known only at runtime. Let's try and understand this with another example. Let's say we have a base class called animal. It has a method called speak. Now animal is extended to create different child classes, say dog, cat or lion. And they have their own unique voices to speak with. So if a variable is created of type animal, it can be associated with its own object or any of its child object. Only runtime reference object would determine the voice of the entity when it is asked to speak. Encapsulation. Encapsulation simply could be termed as technique of hiding critical data into a container so that it doesn't get exposed, and these data could only be accessed via desired access points. Let's see some example. To drive a car, a driver doesn't need to know how car engine internally works, but he can certainly make the engine respond to his instructions by using its exposed or intended access points like accelerator, brake and clutch. Let's see another example. Whenever we switch on a television, we don't know how television works internally. All we do is provide instructions using its remote and television response. Here television remote can be termed as exposed access point and television internal paths as private or critical data. To the right, we can also see the actual software example where critical data, that is height and width, is hidden from outside world by declaring it as private and can only be accessed through desired methods marked in bold. Abstraction. Abstraction is like extracting the essential information or properties that is relevant to defined purpose and ignoring remainder of the information. Abstraction could also be said as technique that is used in identification of hidden or unhidden information. Let's say an example that is provided in the slide. Joe goes to a modeling agency and talks about how good he is as a Java developer. Interviewer has no idea what Joe is talking about. Joey goes for the second interview, but this time it is for the software organization. And what he talks about? He talks about everything other than the Java development. So instead of talking about his development career, he talks about how good he is in modeling. In both the instances, what Joey said made no sense to the interviewer. Although Joey was telling the truth and he is actually good at both the jobs. Had he known abstraction, he would have known that for Java interview he should stick to Java skills and not talk about his modeling career. That brings us to the end of this video. If any of the topics we discussed today didn't make any sense or is still not clear, do let me know in the comments below. If you like this video, please give it a thumbs up and do subscribe to my channel to stay updated. Thanks for watching. See you soon.